Okay, so today we're going to do 8.7, integration by tables and other integration techniques. So in Appendix B, page A3 through A6, and I'm going to have uploaded the PDF file on Canvas, so you don't have to have the book. So make sure you have them handy because this is going to be very, very useful. So we have these tables to help us with integration, and this often will provide, will involve substitution as well. Okay, this is a very short section because you just need all those formulas. Okay, so interact using the tables, integrate, sorry. So if you look at the table, I believe that, well, I have pre-looked at it, right? And you can see that number 44. Okay, and make sure you tell me which one you're using. So in case you use the wrong one, I can give you partial credit, and things like that, okay? So number 44 says the integral of 1 over u squared is the square root of a squared minus u squared du. And then it says that this equals the negative square root of a squared minus u squared over a squared times u plus c. So in reality, this one's super easy because all I really have to do is figure out what is a equal and what is u equal. Okay? And so a equals 1, u equals x, and I just plug it in, plug and chug. So this is going to equal negative square root, and the square root is going to look exactly like the original, 1 minus x squared, over, well, a squared is 1, so a squared, and then u is x. So this is, oh, sorry, I forgot, plus c. So this is going to equal negative square root of 1 minus x squared over x plus c. And we're done. Okay, so the hardest part of this is finding the actual formula that you need. And if you look through the pages, you'll see that it's separated differently. So it's a little bit easier to find them if like you had a cosine or a sine, things like that, if you had e to the x, so on and so forth. Okay, so it is separated by different types of sections, so it shouldn't be that hard to find the one that you need. Okay, so for B, and make sure to tell me on the test, I'm using formula number 44. Okay, if you fail to do that and you get it incorrect, I'm just going to mark it wrong and I'm not going to give you any partial credit. Okay, so you have to tell me which formula you're using. Okay, from the table. All right, so now we have the integral of 1 over 1 plus e to the 2x dx. So for this one, I'm going to use number 84. This is the closest. It's not exactly like number 1a, but it's very similar. So this is the integral of 1 plus e to the u du, and that this equals u minus the natural log of 1 plus e to the u plus c. Okay, well, it's not exactly because my u is really equal to 2x. So my du is equal to 2 dx. Well, I don't have a 2, so then I have 1/2 du is equal to dx, okay? And so we're really used to already using substitution. So this shouldn't be that hard to substitute. So that should give you 1/2 on the outside, the integral of 1 over 1 plus e to the u du. I should have used a different variable. Oh well. Okay, and then, so now it looks exactly, right? But don't forget the 1/2 in front. Oops, sorry. So I get 1/2 times, I'll use a bracket instead. So u is 2x minus the natural log of 1 plus e to the u, so e to the 2x, close it, plus c. I'm going to distribute that 1/2, So that'll give me x minus 1/2 natural log of 1 plus e to the 2x plus c. And we're done. Like I said, the hardest part is looking for the equation that we're going to use. Okay. Okay. So if you look at the cosine sine formulas, I don't have anything with the square root. So I'm gonna have to like use the u substitution, but instead of u, I'm gonna call it v, just so that we don't mix up all the u's here, since all the formula table ones all have u in it, which is what I should have done in the last one, but I didn't do it. I'm sorry. All right, so I'm gonna say v is gonna equal sine x. That would be the best thing to take the integral, and you'll see why, because when, oops, I put so used to. When I take the derivative, I hope you can see, it gives me cosine x, which is perfect because I have that in the numerator. Okay, so let me rewrite this to equal the integral of 1 over the square root of v squared plus 1 dx. Oops, not dx, dv. Okay, so which one does this have similar tones to? I hope you're telling me number 98. And 98 says the integral of du over the square root of u squared plus or minus a squared is going to equal the natural log of u plus the square root of u squared plus or minus a squared plus c. Okay, so technically, what is u? And it's v, right? What is v? Sine x. And then what is a? And a is 1. Okay, so let me plug it into the formula. And so I have the natural log of u, which is v, which is sine x, plus the square root of the radical that I have, sine squared x plus 1 plus c. And that's pretty much it. And I'm done.